Okay. Right triangle. That's what we're gonna choose as a base to study all triangles. I already spent until 2 a.m. doing these notes to make everything easier for you. So if you look at the first page, you've seen this triangle, this one's going to be your base. But be careful. Be careful for the location of the angle. Now, if you look at this triangle, where is the angle?
Follow that.
Yes, the angle on this side. That's me. And the angle on this side, this is the opposite side. This is what,
Okay.
and this is what
Hypothesis.
the hypothesis, okay? What about if we have the same triangle, but the theta here? That means this one is going to be the opposite side. This one is going to be, and this one is going to be the hypothesis. You got it? It depends about the location of the angle. So write down this. If you have the angle on this location, that means this is the opposite side, which is the opposite side for the angle here. This is the side beside the angle. And this one is going to be,
Hypothesis.
and now let's check the shape function. Go ahead.
Is that just HXP or is that H?
No, no.
HYP.
I'm sorry.
HYP.
It's bad English.
Now let's check the trig functions. Now, if they ask you find the sine, I'm talking about this triangle. If they ask you find the sine, it's going to be the opposite divided by.
Hypothesis.
This is the rule. Every time when they ask you find the sine, you're gonna use opposite divided by hypotenuse. Cosine,
Adjacent over hypothesis.
tangent,
Opposite over adjacent.
you got the points? So here's the rules. I'm giving you the rules. But if you can't find the rules, you're gonna go back to the. So I already know the sine for this theta is opposite divide hypotenuse. Cosine is by hypotenuse. Tangent is the opposite over cosecant, the opposite. Now it's gonna be hypotenuse divided by what? No,
No, hypothesis.
opposite. Secant
I thought you
by adjacent, okay? Cotangent,
Adjacent.
just check. This one, if you know the tangent, the cotangent is the opposite. If you know the cosecant, check the secant. Is the opposite. If you know the sine, the cosine is, the cosecant is the opposite. You know that? Okay? Is that clear? That's what we're gonna do next example. So here's the thing, Pythagorean theorem, it's work with right triangles. So always when you have, this is the hypotenuse square, always equal the opposite square plus, you're gonna use this theorem if you're missing one of the sides. That means if you have, here's a triangle. If you have this one 16, and this one is 4, can I find the third side? By using this theorem. Here's another example. If you have here 7, 9, can I find this side? By using the Pythagorean theorem. So always when you have a triangle and you're missing one side and you have two sides, yes, I can find the third side by using the Pythagorean theorem. Let's check the next example.
If one number is on the other side, not seven.
Say it again.
So, 16, is that one?
No, I'm talking about like 16, if this side equals 16 and this side equals 4, do you have this side? I'm gonna say this is X. How I'm going to find this side? By using Pythagorean theorem. The same thing here. if I'm gonna say this is X, I have this side and I have this side. Can I find the third side? Yes, also by using, but I don't feel, we're gonna do an example. I'm gonna try to solve it. So here is the triangle. Check, is that a right triangle?
Yeah.
Because you see, this one is
90
90. So now what I'm trying to find, I know this is the angle 90 degrees, but my theta on this side. So now I need to find, I have the adjacent three, the opposite four. Can I find the
Yeah.
third one?
Yeah.
I'm gonna use the Pythagorean theorem. I'm gonna say I have hypotenuse square equal, I think they can see it here. Square equal
Opposite.
opposite square love adjacent square. That's me. So the opposite side, which is 4 square plus 3 square. 16 plus 9. So the hypotenuse side square equal 25. I need to find not the square, so I'm going to take the square root of both sides. So the square root with this one, so the left equal 5. Now, this side equal. You got it? So let's say we have this theta. And we have the hypotenuse side equal 16. Equal 16. And this side is X. We need to find this side. Now tell me how much going to be the opposite side?
Are we still using 3 as the base?
Yes, they are as an adjacent, yes. So 3, 16, and here's the X. We need to find this side. So you're gonna use the same rules, which is
Hypotenuse squared equal opposite squared plus base squared.
Now I have this side, the hypotenuse exists here, which is 16. Equal the opposite side, which is the X squared. X squared, you can put it in parentheses, or keep it like this, plus the adjacent side, which is basic. 16 squared, how much going to be?
256.
256. Equal X squared plus 9. And what's the next step?
Minus 9 on both sides.
Minus 9 from both sides. So on this side, how much going to be? You cancel. X squared equal what?
247.
247. Next step,
Square root of both sides.
square on both sides. So X is going to be equal. If there is no square root, just keep it like this.
We don't have to,
You don't have to.
okay.
There is no square root. If you got the square root of this number is like a decimal number, keep it 247 or 240.
We don't have to simplify it.
You don't have to. If when you plug in the calculator and you get decimal number, don't simplify it. Just type it like this. Because,
Mine is left like it, like they were.
yeah, yes, because the scientific calculator.
That's from the unit circle, right?
Yes. So. And I'm telling you, you don't have to memorize these angles. But if you memorize the angles, it's going to be easier for you. But I'm gonna give you an easiest way to memorize the angles. Because of course, you're gonna use your notes. So the first angle, check the sine. The sine for the theory, which is 5/6, equal what? Equal half. So what I'm going to do. What I'm going to do, I'm gonna grab a small triangle here. I'm gonna say, okay, here is the angle. Here, okay? So if this angle theory, how much this angle? Don't say. How much this angle? Half of which one? No. How much the angle here?
90.
9. That's mean, what's the complementary angle for this one? 60. So here's 60. Because theory plus 60 is going to be 9. You get the point? So now, if you put the theory here, I always do this angle. If you put the theory here, sine theory is 1/2. 1 is what? Sine,
Opposite over to that, but
perfect. 1/2. This is the opposite. And this is what? That's mean. Where is the opposite for the theory? Here. Where is the hypothesis for the theory? So sine theory is going to be 1/2. You got it? Now, with the same angle, what's the cosine for theory? Cosine theory is square root of 3/2. So cosine theory is square root of 3/2. Square root of 3 is what?
okay, sir.
That's mean where is the adjacent for the theory? So here is. So always when you have this triangle, you can find the sine, cosine, and the tangent. For the theory and for the 60. Now let's go back to the 60. What's the sine for the 60? Opposite over? Is that square root of 3 divided by 2? Where is 60? Square root of 3 divided by 2. What's the cosine for theory? For 60? 1/2. Tangent, square root of 3 divided by 1, which is square root of 3. You get the point? So this angles help a lot to find the sine, cosine, and tangent. If you want to just memorize it like this, it's gonna be fine. Now, what about this angle here? 4,
Quick
5.
question on the triangle, how'd you get the 60? Is it because like it adds up to 90?
Yes.
Okay.
Yeah, complementary angle.
Complementary angle.
Remember, we have complementary angle and supplementary angle.
Yes,
Supplementary, which is the 90. The addition of two angles equal 90. The addition of this one with this one equal 90. I have this angle, it's a right angle, so it's 90. 90 minus 30 is going to be 60. That's why I found this angle.
and if it was supplementary, which is like the
We
way.
can't, with supplementary theory, we're not gonna use it.
Okay,
We're
okay.
talking about just right angle.
Did you get the one to like squares like that?
Okay, look to the angle theory. What's the sign for theory? 1/2. Let's look here. 1/2. If we go back to the first page, the sign for theta equal what? Opposite over. So let's go back here. Here's the theory. Where is the opposite? Where is the hypotenuse? 2. You got it? The cosine is what? Adjacent over. Adjacent is what? Square root of 3. So this is square root of 3 and the same number here. You got it? So if you know this angle, this triangle, you know the angles, the sine and the cosine, but you have to know how I'm gonna find the sine. How I'm gonna find the cosine? By going back to the first page. Okay? Now, what about this angle? Can we do another triangle?
Considering the base number.
Do another triangle. How much the angle here?
90.
So I'm gonna say, oh, if this is 45, how much the angle here? Also 45. Now let's check. Sine 45 is, that's me, how much is the number here? How much the number here? You can say one, or who said one? No one, you said one, it's right, I'm gonna tell you one. If you say this is square root of 2, this one's going to be 1. Okay, so it's the same thing. If you write down 1 here, and square root of 2 here, 1 here is gonna be the same thing, okay? And I'm trying to go with these numbers here. What about the cosine? Square root of 2 divided by 2, that's me, how much the number here? That's it.
But also on the 45 degree angle, since you have the degree are the same, the two sides are the same as
What
well.
about the tangent?
No, on the triangle itself. So
Yes,
if you have two 45 degree angles on the triangle, so you have two degrees that are equal, so your two sides are gonna be equal as well.
yes.
Oh,
Cause some, you can use the same triangle, like I'm never use this triangle, I use these numbers. Like for 45, I'm saying 1 square root of 2. Which is gonna be the same result, because when you say the tangent, these numbers, you can simplify 1 over square root of 2, the same number. But always stick with this one, because you have the same numbers here, you know?
Most people don't like the
1 over square root of 2.
yeah, the square roots at the bottom.
Mhm.
The denominator.
That's mean, if you need to find the sine, you can say, okay, if you have the cosecant, you're just gonna say the sine is gonna be 1 over cosecant. Cosine, 1 over secant. Tangent, 1 over cotangent. And check the next one, is the opposite. Now you see, cosine always goes with what? Always. So if you need to find the cosecant is 1 over sine. If you need to find the sine is 1 over. Here's the two.
Yeah, the codes don't go together.
Yes. The cosine goes with what? With the secant, the opposite. If you need to find this cosine, 1 over secant. If you need to find the secant, 1 over cosine. The tangent goes with what? Cotangent. Tangent, 1 over cotangent. Cotangent is 1 over the opposite. And here's the next. Tangent is what? Sine over cosine. Cotangent is the opposite. Cosine over sine. You get the point? Because you're gonna use it. So sometimes you're gonna use this one, and also they're gonna use this one, it's up to you. These are golden rules. Yes, it's related with the Pythagorean theorem. So every time sine square theta plus cosine square theta equal 1. 1 plus tangent square theta equal secant square theta. And 1 plus cotangent square is going to be cosecant square theta. These are really important. We're not gonna go how we define the rules. You're gonna use these rules. That in case if you have the sine and you need to find the cosine, can I use this rule? Okay. If you have the sine and you need to find the cosine, I can use this rule. By saying sine square theta equal 1 minus cosine square theta. Can I do that? Yes or no?
Yeah.
Just moving the cosine to the other side. From the same rule, if I have the cosine, can I find the sine? I'm gonna say cosine square theta equal 1 minus sine square theta. So you don't have to worry about these rules, but the main rules is 1, 2, 3. The same thing with the secant and the tangent, cosecant and cotangent. You got it? Take the next example.
Meters per month.
Yes. Go to example 1, page 5. see the triangle you have? Now. Can you find the sign? The sign for what?
Opposite over hypotenuse.
Yes, that means it's going to be for what?
8/10.
So here is the triangle. Okay, now I need to find the sign. The sign is, what's the root for the sign? Go to the first page. Where's the opposite from this angle? Over what? How much there? Think about that. How much this number here? We have missing side. How am I gonna find the missing side? But I don't theorem. So I'm gonna say, before I start finding the sine, the cosine, the tangent, I have missing side. I'm gonna say the missing side is x. Here is the missing side. X. But Avogadro theorem is going to be equal what?
Opposite square plus 8 squared
Yes.
plus 6 squared.
That's me, x squared equal, the opposite side for this angle is 8 squared plus 6 squared. So x squared is going to be 64 plus. So x squared is going to be what? Yes? That's mean how much the x?
100?
No, this is the x squared 100. How much the x?
Sorry, 10?
10. The x is 10. Now, do I have the hypothesis x 10? Now, what's the sign?
That's gonna be, 8/10.
8 over 10, that's it. It's gonna take 8 over 10. What's the cosine? 6 over 10. 6 over 10. What's the tangent?
53.
So the tangent, I'm gonna take it here, is going to be 8 over 6. 8 over 6. What's the cotangent? Check here. What's the cotangent?
6.
I can use the rules. And I can say, okay, it's the reciprocal of the tangent. So I'm just gonna flip it. So I'm gonna say cotangent theta equal 8 over,
No, 6 over 8.
6 over
6 over 6 over 8. What about secant?
10.
Secant is what?
The reciprocal of cosine.
The reciprocal of cosine. You know what I'm talking about? You got it? So the reciprocal of cosine, or you can go back to the first page and say, okay, the secant is, and use the whole by, you can use the identities, which is the secant is the reciprocal of the cosine, so it's going to be 10 over 6. What about cosecant? Is the reciprocal of the sine, which is 10 over. That's it. Is that hard? Go ahead.
If it wants the exact values and when we do the division and we get an exact value, for instance, 10 over 8 is gonna be
Oh, you talk about simplified?
1.25.
No, don't type it, because there is still right, but don't type,
Well, I have different numbers, I was trying to do.
don't type any decimal number on Cengage with the sign,
Example,
just like this. But check,
Oh,
this one you can simplify,
so I'm trying to do it,
this one you
but
can
I think
simplify,
I actually understand.
this one. You can simplify it, fine. Still right if you simplify, it's still right if you put the same result. Next example. Now, do we have a triangle?
No, that's problem.
Don't say it. So we have to draw to sketch the graph. Can I do that? So they're telling you to catch the right triangle, so it's right triangle, that means the main angle is 90. So I'm gonna say, okay. This is the 90. Which side you gonna choose the theta?
Uh,
This one?
yeah.
Okay, I'm gonna choose this one. Yes, so we can practice. Okay, so if the theta, this one was, if you say, okay, this is the theta, I needed to know if the theta here or here. It's gonna be the same thing. Now, what's the sign for this theta? This is the opposite. This is the hypotenuse, and this is what?
Adjacent.
You got, so the same thing. Always the opposite is the opposite of the angle. The adjacent is that side of the angle, and this is the hypotenuse. Okay? You got it? Now, what do I have?
The adjacent and the hypotenuse.
We have the cosine. So this part here is, and this part here is what? The hypotenuse. That's mean, where is the adjacent? How much here?
15,
And how much here?
17. And then.
So Pythagorean theorem. So in this case, you're gonna use Pythagorean theorem to find,
Yeah.
okay, let's say the opposite side is what? X. Go ahead, find the X.
It's right there.
I don't know, right? The value of X. How much you got?
We're, I got this wrong.
I know how much, like, I didn't do the math. So I have 17 here squared, right? And I have X squared here, plus what? 15 squared. How much 17 squared? 2, 8, 9. There's the X squared plus 225. That's mean minus 225 from both sides. How much the X squared?
64.
Square root from both sides. So X is going to be equal. That means X here is equal. Now, when you find the value of X, everything is going to be,
Plug and play.
yes, just use the rule. Now, what's the sign? What's the sign?
Opposite of
Where is the opposite?
8,
8 over
17.
8 over 17. What's the tangent?
Opposite over
Where's the opposite?
8,
15.
15.
So it's going to be 8 over 15. What's the cosecant?
17 over 15.
17 over?
15.
I don't know. The cosecant is the opposite of, sorry, the sine, you see? What's the secant? 15 over 8. The cotangent, there's something wrong with the secant.
The secant should be 17 over 15.
Yes. Not 15. 17
Over 15.
over
15.
15.
Oh, secant is the reciprocal of cosine.
But we don't have the cosine. The cosine,
The cosine's up there though.
Cosine was given.
oh, the cosine is given perfect. So the opposite of this one is going to be 17 over 15. What about cotangent? Is the opposite of what? Tangent. So it's going to be 15 over. That's it.
Oh, because I did the.
Such that sine theta equals 0.6. Find the value of cosine and the tangent using what?
Trigonometric identities.
That's mean which one you have to use. Not the first rule, the identities, which is the three rules. The golden rules. Yes, you have to use these rules. But always there's another way to solve it, because if you say theta equal, like the other way, I'm gonna say sine theta is 0.6. Is that the same thing? 6/10?
Yes.
6/10. The 6 is the opposite, 10 is the can I find the adjacent? And then I can find the tangent, the cotangent, whatever I want. But they ask you to use what?
Trigonometric identity.
Identities. That's mean I have the sine. The golden rule is says sine square theta plus cosine square theta equal 1. Yes, I know the solution is here. I'm not gonna care about this one because I need to solve it. The sine is 0.6. So 0.6 square plus I need to find the cosine. Cosine square theta equal 1. Now how am I gonna find the cosine?
Minus the, oh, first you gotta multiply 0.6 by.
So it's going to be 0.36 plus
Cosine squared.
cosine square theta equal 1. Now cosine square theta is going to be 1 minus
0.36.
0.36. How are you going to be
0.64.
equal 0.64? This is the cosine square. What about cosine? Theta is going to be equal. What's the square root of 0.64? 0.8 is. Now, they ask you to find tangent. How are we gonna find the tangent? By using the identities. Go back.
When you get a decimal, do you have to round it?
You don't have to. If they're telling you round it, you're gonna round it. If not, just keep it like this.
So like if it's 4, you leave it with 4.
You-
Oh, okay.
So it's the closest identity.
Check here, what is it on page 3? Trig identities, right?
1/.
That's mean all these are the identities. So, yes, how are we gonna find that tangent?
Sine over cosine.
Sine over cosine. So the tangent theta equal sine theta over cosine theta, which is equal. The sine is 0.6, the cosine 0.8, and you're gonna get this. Got it?
No.
Who said no? Okay, let's do it again. Which is good if you say no. Which part? The second one?
I got the first part, but why did you reduce past 61?
Wait. Why I reduce what?
Why did you reduce it down to 0?
Because cosine square theta equal cosine square 0.64. I need to find the cosine. So I'm gonna take the square root for both sides. That's me taking the square root for both sides. Cosine theta equal 0.8. The square root of 0.64 is 0.8. Okay, so this is the cosine. Now I need to find what? Tangent, which is sine over
Cosine
sine how much?
0.06.
Cosine.
0.8.
Just divide these two numbers, you get 0.75. Yes?
Yeah.
0.
There'll be another 0, they're both points. They're already decimal points, and there'd be,
No, because this one will go with this decimal. And divide 6 by 8, going to be 0 point, which is like actually 3 divided by 4. Skip steps. I'm going. Okay, so the secant equal 9/7. We said
Hypotenuse over adjacent.
Yes, that's mean this is what, and this one is,
Yeah, it's his own.
so, okay, that's mean this side is 9,
Yes.
and this side is
No,
7. Now, can I find the third side?
Yeah.
yes.
By using,
Do
okay, that's mean,
A squared plus B squared.
well, you can do that, it's fine.
Opposite square.
Opposite square plus, this one is 9 square equal, the opposite,
Is X. Which
let's say this is the x, so you can. Plus 7 square. So it's gonna be 81. X squared plus minus 49 from both sides. X squared for what? So for what? 32. Get the square root from both sides. X squared equal. Not x squared, equal what? Don't give me a decimal number. Square,
4 squared root of 2.
can you simplify it?
Yes,
Can you simplify?
yes,
How much?
it'll be 4 square root of 2,
So 32, is that 2 times 16?
yes.
So I'm gonna say, okay. 2 times 16. X equal, what's the square root of 16?
4,
It's gonna be out of the root. Do you have square root of 2?
no,
Keep it. You got it? So now this side is equal
4 square root of 2.
square root of 2. Now can you find the sine, the cosine, the tangent, the secant, the cosecant? Can you find all these 6 different functions? Yes, but I already have the triangle sides. You got it?